Okay, so hello guys. We will start a new unit today. Is called trigonometry in right angle. So it's not that hard, so don't freak out. Okay, so let's get started here. So what is a trigonometry? So Paul, you wanna go? Just rotate.
Alright, trigonometry is a branch of mathematics that refers to the relationship between the side lengths and angles of a triangle. So basically it's just about triangles and the relationships between like the sides and the angles and stuff. So from geometry to the application of astronomical research, this field appeared in the Hellenistical Hellenistic world in the 3rd century BC. So this has been here for a long time. The special right triangles. There are specific right triangles in trigonometry which would prove
Marco, go
crucial.
ahead.
Oh yeah, that would be crucial in solving functions. Some triangles have specific properties such as unique side ratios. To keep things simple, the hypotenuse of such triangles will be set at 1. However, this value can vary. So the first special right triangle is the 30, 60, 90 triangle, where one side is 30 degrees, one side is 60, and the other one's 90. The formula the pattern for this is where the hypotenuse is double the side adjacent to the 60-degree angle. Adjacent means next to, so it would be x in the picture, and the hypotenuse is the side opposite of the right triangle, which is 2x. The side adjacent to the 30-degree triangle is x times square root of 3, and where x is the side adjacent to 60. And using these properties, we can derive certain trigonometry functions and their values.
Well, okay. So and then our next special triangle is a 45, 45, and 90 degrees triangle, which in a triangle it has 190 degrees and 245 degrees. And then so for this, the two sides are equal, which shown on the picture on the screen. So which A right here is equal to the B right here. And then also the hypotenuse is a squared. I mean like square root right here. And then yeah. And then if you use a square plus b square equal to c square, you should find a side if you are missing one. Yeah. So make sure you write down like this formula since it's really important. Okay, so let's go ahead.
Alright, so here are two practice problems. Feel free to try it out on your own first, right? Alright, so let's start on the first problem. So for number one, you want to find the value of x. So you know that from a 30 60 triangle, we know that the hypotenuse is equal to 2x, and the and then the longer angle is equal to x root 3. Since over here you know that this is 6, so you know that 6 divided by 2 is equal to x, so x is equal to 3. So then x has, and so then so then this is x, but it's not, okay, so this is then equal to 3 times x, 3 times root 3, x times root 3, so it's equal to x root 3. For this one, I'll do this one. So as you can see, this is a 45-degree angle, which means that the other one is 45 degrees as well, since this is a 90. So that would mean it's a 45-45 special triangle. And since we know that this angle is 2 root 3, that means this would be 2 root 3 as well. I'm pretty sure. So the thing says that this one would be 2 root 3 times square root of 2, which would mean that it would be 2 root 6 for the hypotenuse.
Cool. Okay. Let's move on. So here's more practice problems. So maybe you guys can try yourself again by yourself, and then we will check answer like about 1 minute. Okay, so for the first one, the formula is that c equal to a square root of 2. So we notice that here the hypotenuse is c, which is 16, equal to a square root of 2. So like a is just represent the x right here. And then you do like you divide the root 2 over, right, this side, and then you should got 16 over root 2 at the end. Polo, you want to continue?
Yeah, sure. For the second one, you know that it's a 30 60 90 triangle. So from that you know that the angles are x, 2x, and x root 3. So you know that x has so you know that x wait no you know that the hypotenuse is equal to 2x, and you know that 12 currently is equal to x root 3. So you have to yeah, so you have to divide wait yeah, so you have to divide 12 by root 3. So 12 over root 3, that's equal to x over here. So you can't have that as a normal thing, so you have to get rid of the rational on the bottom. So that's equal to 12 root 3 over 3, which you can simplify into 4 root 3. So x is equal to 4 root 3. So then you know that y is equal to 8 root 3 because y is 2 times x.
Yeah, so make sure you check answer by yourself.
Basic triangle knowledge. So the sum of three, here are some like basic stuff about triangles. Sum of three angles is 180 degrees. So yeah, and the right angle, there's one angle that is 90 degrees. And also for right angles, the two remaining sides add up to 90 degrees. And the longest side for the right angle is called the hypotenuse. There are types of triangles, and you can classify them by length of sides or by internal angles. So equilateral triangle means that all sides are equal, which also means that all the angles are equal. For isosceles triangles, there are two sides that are congruent, which also means that two angles are congruent. For scalene, all three sides are different lengths. By internal angles, there's one right angle. For acute, there are at least two angles where all the angles are all below 90. And for oblique, there's one angle that is above 90 degrees.
So make sure you write down some notes if you like needed. So if you are not finished your notes, please pause the video right here, and then we're going to moving on. Okay, so here is a like two really important formula. So first one is law of sine, and then the second one is law of cosine. So the first one, law of sine, you have a not right angle, but you have a triangle right here. And then, so for law of sine, you have sine A, which is the angle right here. And then you divide that angle, like you over with this lens A right here. So it's just a opposite, like, what do you call it? Opposite lens. So if you have an angle right here, so the opposite one is right here. And then exactly same for sine B. You have a opposite lens right here. And then same thing for C. So I know right now is a little bit confused, but if we go over a couple questions for like next couple slides, I think you should be okay. It's not really hard. You're just plugging the number that you have. But just write down your formula right here on your notes. And then for law of sine, so you have a triangle right here. And then I'm pretty sure you have A, B, C lens. You have a number. You have like 3 number. and then plug in your formula right here, and then you can find a angle A, angle B, or angle C. So if you want to find angle A, that is means you need to use the first formula right here. If you want to find angle B, you need to use the second one right here. If you want to find angle C, you need to use the third formula right here. And then the things is that the problem will actually give you the length number right here, and then you can just like find a angle with the given number. So we will like look at some actual example in the next few slides. So make sure for this slides you just write down the formula notes so you can use them in the future slides. Give you guys like 30 more seconds to write it down. It's really important. Okay, let's move on here.
Alright, so vocabulary. So adjacent, that's the side that makes up a certain adjacent is basically alright, this definition isn't that good, but okay, I'll just do it here. So yeah, let's say we have a 30-90 triangle, right? Yeah, 30-60 triangle. So yeah, this is 30 and this is 60. Alright, so the adjacent side of, let's say, the 90-degree angle would be these two, and then the adjacent side of this one would be these two sides. Okay, so alright, the opposite side of an angle, let's say, is over here. So it's just it's pretty self-explanatory. It's the side that isn't touching the angle physically. And then the hypotenuse is just the longest angle. So, longest side. So for this example, it's over here. One trick to find the longest angle is that, the longest side, the hypotenuse, is that it's always the opposite of the angle that's the biggest in the triangle. So in this case, 90 degrees, this is the biggest angle. That's why this is the hypotenuse. So yeah.
Yeah, just have a clear understand right here. The direct the right triangle, the picture is right here. So if you want to like draw it on your notes or whatever you want, write down. Here is more like clear. So for this rectangle, I believe this angle is the mentioned like angle. So the opposite side is right here, hypotenuse and adjacent.
So we're gonna be talking about SOHCAHTOA, which is a way to remember the sine, cosine, and tangent. So to begin, to find the sine of angle measure, like a certain angle measure, you can use like formulas to find them. So sine of an angle would be equal to the opposite of that angle divided by the hypotenuse, which is why it's called so, because sine opposite over hypotenuse. For cosine, it would be adjacent over hypotenuse, and for tangent, it's opposite over adjacent. For inverse functions, define cosecant, it's equal to 1 over sine, which is also equal to hypotenuse over opposite, which is basically the sine reversed. And for secant, which is the inverse of cosine, it's hypotenuse over adjacent, and cotangent, the inverse of tangent, is equal to adjacent over opposite.
Yeah, so make sure you write down the notes for this slides. Is really, really important, because the basic like knowledge that we'll learn is like only on this slide. And then for like future slides is only practice, I believe. Maybe some word problem, but not right now. And then, so since it's really important, I'm gonna like use those in a triangle, right triangle right now. So just need to explain one more time. Okay, so for SOHCAHTOA, this formula, those sine, cosine, tangent formula is only can use in a right triangle. So if you have something like this, you cannot use this formula. So it's only used for a right angle. And then for sine, if you have a mentioned like angle right here. Oh, and then like this mark right here, this one, like something looks like 0. This means the angle that they want to use. So it's called mentioned angle. And then for this one, opposite side is right here. So this is the opposite and hypotenuse. And here is the adjacent. So sine is opposite over hypotenuse. So if we have opposite number for 4 and hypotenuse for 5, you just forward 5, and then that's the sine. And cosine is adjacent if we have like 4, 5, 6. Then, oh yeah, so it's just 6 over 5. So it's adjacent over hypotenuse, 6 over 5. Tangent is opposite over adjacent, 4 over 6. And then for cosecant, secant, and cotangent, those are just the inverse like form of the sine, cosine, and tangent. You don't really need to remember them. Just like remember to like change, switch up right here. So for cosecant, if we use this formula in like this rectangle here, it will be hypotenuse over opposite, so it's 5 over 4. Secant is hypotenuse over adjacent, is 5 over 6. And then cotangent is adjacent over opposite, is 6 over 4. Yeah. So just write down your notes right here. And then you can actually see some practice problem in the next slides.
Alright, so for some practice using SOHCAHTOA. So for the first problem, we have sine 60 degrees. So sine 60 degrees, that's equal to the opposite of opposite over hypotenuse. So that's equal to yeah, that's equal to opposite over hypotenuse. So then that's equal to um yeah, wait. Okay, opposite over hypotenuse, so that's equal to root 3 over 2, since you know that the opposite of this angle, which is this one, this is root 3, and then the hypotenuse is 2. So yeah, I do I do the next one or no?
Yeah, you can just go over it.
Okay, for the next one, cosine 60. So we got cosine, which is still this angle over here, 60. This is 30 and this is 90. Cosine is the SOHCAHTOA, so cosine is adjacent over hypotenuse. So that's the adjacent side, which is this one, over hypotenuse, which is this one. So this is 1, since the adjacent side is 1, and then hypotenuse is 2, so it's 1 over 2.
Okay, so for the rest of the problem, because those questions, so 1 to 6 is really popular questions you can see on the test or your homework. So I put a table right here. This table shows all the popular like question that you may see on the test or your homework. So if you see like for example like sine 60, so you first find, okay, here is the sine and 60, and you match up those together will be root 3 over 2. So you can just find the answer at the table. And then the special one is number 6 right here, tangent 90. So tangent 90, you can see right here is undefined because it don't really have a tangent 90 on the right triangle. So it's just undefined. Make sure you remember that. And then yeah, make sure you write your table down on your notebook. Okay, so if you don't finish your notes, please pause right here. And then we will moving on. Okay, here is more like specific explanation for why tangent 90 is undefined. So go ahead, Marco.
So why is tangent of 90 undefined? So the reason tangent is, it has to do with the property of fractions. So tangent of a degree would be equal to the sine of that degree over the cosine. And tangent of 90 would be equal to sine of 90 over cosine of 90. And since sine is opposite over adjacent, hypotenuse, it would be equal to 1 if it's 90 degrees, while cosine, it would be equal to 0. And 1 over 0 is undefined, which would mean it's undefined.
Okay, cool. So if you want write this down, feel free to. Okay, so right now we're going to do like some actual problem. So for those problems, I'm pretty sure you need to use your calculator with like sine, cosine, tangent. So make sure like you have it. If you don't, you can like search on Google or online. So yeah, so for the first one, I'm going to like go over it like with you guys. Okay. So it's pretty sure they already give you like they already circle your like opposite and hypotenuse. So we know that is a sine problem since sine is opposite over hypotenuse. And then O is just represent opposite and H is represent hypotenuse. So sine 22 and 29, I mean, equal to opposite over hypotenuse, that is x over 8 right here. And then, yeah, so go ahead, try like 1 minute by yourself, like to try how you solve for sine 29 equal to x over 8. So just try it on yourself. Okay. So basically is same things as you do a like fraction, divide or like multiply. So you multiply 8 to like this side. So right now you will use your calculator to calculate that. So sine 28 times 8, it probably equal to 3.88 if we round up to 2 decimal places. So 3.88 is equal to x. And then you know that your opposite, the x, is equal to 3.88. Paulo, do you want to go over next one?
Okay, so for the next one, you have 5, 19, and A, and then capital A, and B. So, if you're trying to find, let's say, A, oh wait, so yeah, if you're trying to find A, you can use SOHCAHTOA, you can use sine, cosine, and tangent. So if you look at it, so you can use this angle, the adjacent side, and the hypotenuse side to find the thing. So this is also another adjacent side. So you can use this. Wait, oh wait, no, wait, you use this, never mind. You do this since you know Pythagorean theorem. 5 squared plus a squared is equal to the hypotenuse, which is 19 squared. So then you get 25 plus a squared equals 361. So then you can, using the calculator, you can find that a is equal to 18.33. So now that you know that a is equal to 18.33, you can find the, that's it.
Yeah, here is a like really simple way that you can find, but if you want to use your like law of sine, if you remember that like formula, you can also use that too. So that works like sine 90 over 19 equal to, oh yeah, never mind, you cannot use that because since you don't have the angle right here, you don't know those two angles, so never mind. Marco, go ahead.
So this is the unit circle. The unit circle is a diagram that we can use to display how the various trigonomic ratios are related to each other's. And it utilizes the points on the circle as a way to demonstrate the graph is based on a radius with circle with radius 1, and it utilizes the points on the circle as a way to demonstrate the trig ratios. So remember that cosine is always the x value and sine is always the y value. And one way to remember this is that c comes before s. So you like on the right, that's the thing, and you can see how like you can use it to figure out like convert between like radians angle measures and like the lengths and stuff for like the using the coordinate points.
Okay, so what is pi unit means? So you basically this is related to the unit circle that is right here. And then the unit circle is really important, so make sure you write like your thing, your notes, write down your notes. Or you can download one picture on like the internet or something like that. So if you have like pi over 6, if you go back to the unit circle, pi over 6 right here, you can see is equal to 30 degrees. So you can always find like those pi things on the unit circle with match up degrees. So it's really easy at that way. So yeah, and then some like special ones, just pi is equal to 180, 2 pi is over 360, and pi over 2 is equal to 90 degrees. So that is means if you have a things right here, this is over 2 pi is equal to 2 pi, and oh yeah, the whole circle is equal to 2 pi. And then if you have half circle right here is equal to pi.
Alright, so for this one you wanna practice finding sine and cosine of the thing. So you can use the circle to do it. So in the circle thing, the unit circle, you can find the thing for 1/2, 3/4. So wait.
Let me pause you real quick. Isn't it just like x is equal to cosine and y equal to sine?
Oh wait, yeah, never mind. Right, yeah. So yeah, okay. So sine is equal to 1/2, and cosine is equal to 3/4.
I
right?
think sine is equal to 3/4, and
Oh,
cosine.
oh wait. Oh
is-
right, yeah.
Yeah,
I forgot about this
it's okay.
stuff. Yeah, so sine is equal to 3/4 and cosine is equal to 1/2. And then so it's the same for these as well. So yeah.
So if you switch that up, so cosine comes first, and then sine comes second. So x is equal to cosine and y is equal to sine. So it's pretty easy right here. Wait. Okay, so we are going to end early today. And for next week, we're gonna find more practice problem about law of sine, law of cosine, and the SOHCAHTOA formula thing. So yeah, make sure your notes are complete so that's easier for next week. And then yeah, that's it for today's lesson.